Hello and welcome to the third of a series of 5 videos on finance. This one is about annuities and the amount of an ordinary annuity. What is an annuity? An annuity is a regular series of payments. Regular means it happens at a regular interval of time, like every month or every week or every year. And it's the same amount of money every time. Some examples of annuities are rental payments. If you were to rent an apartment and you got to pay rent, you'd pay rent every month, and it would be the same amount every month. So that's a regular series of payments. That's an annuity. If you buy a car and you finance that car, then you got to make car payments. So that would be an annuity. It's the same amount every month. I guess car insurance is also an annuity because every month you make a car insurance payment. If when you're a kid and you're getting an allowance from your parents, that is a regular amount of money on every week or every month. So that could be considered an annuity. And finally, saving up some money from every paycheck. Let's say a person has a part-time job and decides to save up some money every month from their paycheck and put it in the bank, save it up. That would be a form of an annuity as well. We're going to concern ourselves with the amount of an annuity, and that's the result of all the payments saved up and added up. Here's an example. Calculate how much money you will have saved if you deposit $6,000 into the bank at the end of each year for 4 years. And I'm going to pretend that money earns interest at 10% compounded annually. It doesn't really, but for the sake of the example and making it simple, let's pretend that it does. So, the solution. The solution involves drawing a timeline. It's a good way to communicate what you're thinking. It's called a timeline. Here's a timeline. We'll notice that in this timeline, time ticks to the right. So this is now, and then a year goes by. We've got 1 year, 2 years, 3 years, 4 years. So nothing happens now except, well, okay, something happens now. It's just the only thing that happens now is a decision is made. I'm going to save up $6,000 a year. Then the year goes by. This is the year going by. This dot represents, okay, I'm going to invest $6,000 in this dot. That's the first investment. And then this is the second one, and the third one, and the fourth one. And then the question is, okay, so how much money have you got saved up in the bank? So let's find out. At the very end of the 4 years, you're standing in the bank and saying, how much have I got? And the teller, the bank official, says, well, sir, miss, you just handed me $6,000. So that one hasn't earned any interest. That's just worth $6,000. It's in your bank account. But 1 year previous to today, because we're pretending we're 4 years in the future, 1 year previous to that, you also gave us $6,000, but it's been sitting in the bank earning compound interest for a year. So let's take a look at what that one's worth. We'll have to use our compound interest formula, and here it is here, P times 1 plus I to this exponent n here, but it was only 1 year, one compounding period, and so that one has matured to be $6,600. Again, considering the previous payment to that, go back 1, 2 years, and we come to this investment, which has been sitting in the bank account for 2 years as of this date. So let's see what it's worth using the compound interest formula from previous lessons. 6,000 times 1 plus I to the n, but n is now 2 because there's 2 interest periods we can see on the timeline here. So when we multiply this out on a calculator, that particular investment is worth $7,260. And finally, on this date, 3 years previous, $6,000 was deposited and sat in the bank for 3 years. And so n is now 3. So this is p times 1 plus I to the n, with n being 3. And we use a calculator to determine that that particular investment is worth $7,986. And so how much is it all worth all together? We draw a line and we add them up. $27,846. Let's notice a couple of things. First of all, $6,000 was deposited 4 times. So $24,000 was invested, but that investment has matured to $27,846. That's one thing to notice. Another thing to notice here is that there was 1, 2, 3, 4 investments, and the highest exponent I see is 1 less than 4, 3. Because what we have here is a geometric sequence. AR to the n minus 1 in each case. That's why this is 3 is 1 less than 4. And what we have here is the sum of a geometric sequence, which is called a geometric series. So this is a financial application of the previous unit on geometric series. Now, consider for a moment, if payments were made every single month, there'd be 48 of these things to calculate, and nobody wants to do that. So good thing there's a formula. And the formula also it comes from the previous unit, but it's been modified only slightly. Let's take a look. Formula for the amount of an annuity. Here it is. Another formula to be learned. The amount of an annuity A is R times 1 plus I to the n minus 1 over I. And this is what they all mean. R stands for the regular payment. In our previous example, that regular payment was $6,000. I stands for what it always stands for, the interest rate per interest period, and N stands for the number of investments. So in our previous example, there was four investments. So N would be 4. And so we can lay them out from the previous example. R is the 6,000, R stands for regular investment, I is what it always is, and N is the number of investments. Plug them in and do it yourself on a calculator, and you'll find that yes, we get the same exact number, $27,846. But do it yourself. Let's do another example. When the Maestoroviches had a baby girl, they decided to put $1,000 into the bank on each of her birthdays so she could have an education. How much money would their child have on her 18th birthday if money earns interest at 9% compounded annually? Solution: use a timeline to illustrate your thinking. So here it is. There's 18 investments here, so we're not going to show them all because that's too many to show. She's born, and a decision is made, not an investment. Her first birthday, money is invested. This represents missing birthdays that happened, but they're just not illustrated on the timeline. So this is like ... an ellipsis. Her 17th birthday and her 18th birthday. I've shown 3 of the 18 investments. And the discussion is the same. How much would she have on her 18th birthday? The discussion is the same because, well, on her 18th birthday, her parents put in $1,000, but it didn't earn any interest because it was put in on the very day. 1 year previous, on her 17th birthday, $1,000 was put in, but it's times 1 plus I to the exponent 1. And it goes all the way back to her first birthday. And this 17 here is one less than the total number of investments. And it was 18 investments. So that's why this is the number 17. It's always one less. Plugging into the formula, well, the regular investment is 1,000. I is 0.09. And N is the number of investments, and there's 18 of them. Plug them in, take a calculator, and do this yourself. $41,301.34 on her 18th birthday. What a nice birthday present for her. Notice how the Majstoroviches only put in $1,000 times 18. So they only put in a total of 18,000, but it matured over the years to become $41,301.34. Baby girl Majstorovich will have $41,301.34. Example 3. How much money must you deposit into the bank every 3 months? So this is coming at it from another angle. How much money must be deposited every 3 months? By the way, that's 4 times a year because there's 12 months in a year. So this is quarterly investing. How much do you have to deposit every 3 months in order to save up $12,000 after 5 years if money earns 6% compounded quarterly? Well, let's find out. There's our amount of an annuity formula, and the regular amount is a question mark. However, I we know to be 0.06 divided by 4. So the I value is 0.015. N is 20 because N is the number of investments. The N value here is how many times was there an investment. And now this is every 3 months, which is 4 times a year for 5 years. So 4 times 5 is this 20 right here for N. Plug them all in. And now we've got a little bit of math to do. We have to solve for R. So we'll take the denominator on the right side and move it over to the numerator on the left side. And the entire bracket factor here, it's a bracket factor, has to be divided over onto the left side. This isolates R. And now the calculator work gets a little more challenging. R equals $518.95. Again, one has to take their calculator and do it. Here's a couple of suggestions. There are brackets on your calculators. So if you figured out the numerator, went 12,000 times 0.015, and then hit equals, and then hit divided by, you can open a bracket and write in 1.015 to the 20 minus 1, and then close the bracket. And then hit equals, and it should give you this number. So do it yourself. Learn how your own calculator works. They're all different. Final example. Therefore, $518.95 must be deposited every 3 months to realize this goal of $12,000. A final example. Calculate the approximate financial cost of being a smoker from age 15 to age 55. Now, I went down to the variety store and I found out that currently a pack of smokes, a package of cigarettes, costs $12 a pack on average. And I've known smokers over the years, and from my experience, the smokers, when I asked them, they said they smoked about a pack a day. Heavy smokers might smoke more than that, light smokers might smoke less than that, but that sounds like a good average. So let's also pretend that money earns 10% compounded monthly. This is not so unreasonable to pretend, because from age 15 to age 55, that's 40 years. And yes, if you look back over the Dow Jones Industrial Average stock market, it has easily gained on average 10% a year. So this is not unrealistic to assume that one could get 10% per year on their money over over a 40-year period. Let's find out how much you could save if you decided to save money instead of smoking it. Let's find out. Well, we'll need the amount of an annuity formula. The amount of an annuity, R times 1 plus I to the n minus 1 over I. Now, to plug in, we figure that R, the regular investment, this is every month. I said 30 days a month. Sometimes there's 31. But 30 days a month multiplied by 12, because I said $12 a pack. So $12 a day for 30 days. That would be $360 every month. How many months? Well, the n value is 40 years from age 15 to 55. 40 years times 12 months every year, so 40 times 12, 480 investments. And the I value? Well, we're taking 10% and dividing by 12 because we're making an investment every month. And the calculator says 0.00833. Plug them in, do the math on a calculator, and we find out that at 55, this person who decided to save money instead of smoking has a nice tidy sum of $2,273,900.